we can get started, I think. Lucia, do you want to tell something? Or
Hi, everybody. Thank you for coming today again, and Matthew for doing the second part of the webinar. Just let me just check quickly the email of the LCN because I just received a pop-up about somebody saying that they don't have the link. So I'm just going to verify that. And yes, thank you everybody for coming. This is the space for you guys to ask questions, to make comments, to see how this last week went on when you practice with the tools that with the practice that you did this last week, and let us know if you need anything else. I'm just going to check quickly the email.
okay, thank you. Yeah, miarahaba antsika rehetra tonga amin'ny andiany faharoa amin'ny QGIS training antsika androany dia araky ny voalazan'ny Lucia izay ataoko traduction tsotsotra fotsiny manantena zany fa nanao an'ilay exercice tany an-trano zany hoe niinstaller an'ilay QGIS nareo dia nanao kely an'izay exercice ny ressources efa nameny mafio misaotra betsaka azy tsika amin'ny fiofanana izay omeny androany. Dia raha misy ny olana na misy ny zavatra nisakatsakana tamin'ny na ny installation na ny fantaniana dia androany zany ny fotoanantsika ametrahana sy amalinana izay fantaniana izay dia aza misalasala raha misy fantaniana rehetra dia ezahana tena tsara to da amin'ny teny anglisy mihitsy dia amin'izay tsy afaka tsy manao traduction foana satria efa hitako mambony be daholo ny English proficiency anareo dia tsara be zany. Yeah, thank you everyone. So we can get started. Thank you so much, Matthew.
All right, thank you everybody. Thanks for joining again. Kind of how I envisioned setting this up this morning is I've already seen a lot of questions from folks. I took the questions from the chat last time, as well as some of the questions that y'all submitted via the survey, and went ahead and we'll go and answer each of those questions to start out. And then when we're done with that, then we can open it up more broadly to any additional questions that you haven't had a chance to bring up yet. Sahino, do you need to translate that before I dive in, or are we good?
Yeah, just one sentence to summary. Ny fantaniana zany afaka apetraka amin'ny chat fa kosa ny anomboantsika azy dia ny fantaniana izay hita amin'ny heriny priorisentsika aloha nisy taminareo nametraka fantaniana tamin'ny heriny amin'izao no ametrahantsika azy nisy taminareo ihany koa nametraka tao anatin'ilay survey na le Google Form na le finy dia iny aloha no ataontsika rehefa vita zay dia mandeha amin'ny fantaniana manaraka atao amin'ny chat. Misaotra betsaka antsika rehetra manaiky ny fandaminana. Thank you.
All right, thank you all. So we'll kind of go through these in a, well, in the way that I thought might work well. So we just got a chat in the, or a question in the chat this morning, but I also saw this question last week as well, specifically asking whether there are any tools available that allow us to detect changes in forest cover. So specifically thinking about things like forest fire as well as illegal logging. Is there any way we can get a handle on being able to recognize when that is occurring within specific areas, be alerted to it so that way it can be addressed? And the answer is yes. Someone has already tackled that, and it's done. And I wrote a brief response in the chat. I'm going to go ahead and just share my screen as well. And it's actually a pretty well-known group that's based here in DC, and it's called Global Forest Watch. And they have a variety of, and actually interesting that you brought this up, because this was one of the topics that we at the Lemur Conservation Network just thought we might cover later on in a seminar in the future. So our plan was to eventually actually have someone come from Global Forest Watch and present, or that I would present the information on this website. But essentially, so to be more data to be, or more information to be provided at a later date. But if you come to this website, and then you can go and I don't know if my connection is going to be quite fast enough this morning, but you can, look at explore recent deforestation and fire alerts. So where have there been alerts where forests are being, destroyed? You can look at trends in forest cover. So where has forest cover changed? So, and the other thing is they actually have an email system whereby you can sign up and say, this is the area that I'm interested in. If anything happens to this area, please send me like an email that, that alerts me that there's tree cover loss happening. So this website is really a great place to start. And, like I said, we were thinking about going over this anyways in the future. And so I think your question kind of gives us more motivation to schedule a seminar to talk specifically about this website and how to use it. But if you want to dive into it right now and you don't want to wait, go here and start exploring, because what you're looking for is someone has already tackled it right here. So you don't need to do it all in GIS yourself. They've already automated it all in this interactive website. So Hannah?
Yes. Yeah, ny Global Forest Watch, tsy haiko raha iza no iza aminareo no efa zatra tsara na hoe iza mbola tsy nahafantatra mihitsy a. Ny fanontaniana teo zany a le amin'ny ankapobeny hoe ahoana no ahafantarana an'ilay resaka hoe menace zany anatina toerana anankiray, anatina area anankiray a, de aiza no ahitana an'izay. De ty site web ana Global Forest Watch ty a de manome zavatra maro de maro a, manome info be da be a. Hitanareo ny nanaovany Mathieu azy teo a, Mathieu azy teo no nandeha tamin'ny Interactive World Forest Map teo izy de nijery a, ary de afaka koa zany mandefa email zany amin'ny zareo a, de manontany hoe raha misy zavatra mitranga amin'ity spécifiquement amin'ity area anankiray ity de mba ilazao zahay, de manasa anareo hijery tsara anatin'io fa tena intéressant be mihitsy izy io a, hijerevana an'ilay resaka déforestation, resaka feu hitako teo zao a, de zay zany no afaka mijerena anazy. Tsy haiko hoe nisy adinoko ve misy?
Angamba ny LCN fotsiny resahany teo, efa nanana planina hoe hanao webinaire sa ina manokana momba an'izay forest cover change zay no ohatr'izany, forest loss.
Ie, ay marina zany. Okay, thank you.
All right, thank you, everybody. All right, let's dive into some of our other questions that we had. I'm going to go ahead and pull up where we left off last time. One of the first questions that came up that's pretty straightforward is the how do we load the OpenStreetMaps? So I'm going to go ahead and actually remove the OpenStreetMap layer that we had originally put here, just so that way you can see as I walk back through the steps about adding it back in. So here are our data layers that we were looking at last time. I've got the red-ruffed lemur occurrence points, silky sifaka occurrence points, the roads, major roads of Madagascar, a forested cover from 2014, and then a set of polygons that shows protected areas in the area. So the first thing that you need to do, if you haven't done it already, is come up to the plugins menu. Come down to manage and install plugins. And you'll need to do this for every plugin that you want to install. Now, plugins are free, so they don't cost any money. They're just additional little features for the program that don't come with GIS or QGIS when you originally download it. So you just need to add them on. So now the plugin that we're interested in is Quick Map Services. So you'll come down here to Quick Map Services and click on it. And then there'll be a little button here that will say install plugin. Now, again, I don't need to install it because I've already installed it. So I'm going to go ahead and click close, but you'll need to click install plugin if it's your first time. Then we'll click, I'm going to go ahead and click the close button. Now at this point, what happens is if you come over now to web and you go down to Quick Map Services, and from Quick Map Services, go to OSM, which stands for OpenStreetMaps. The one that I tend to pick most often because it's the most relevant and simplest to look at is the OSM standard. I click on OSM standard. And you can see that the OSM standard layer has now been added. There's a little check mark next to it showing that it's being displayed. And now again, we can see the shoreline along with the, the blue water. Sahana?
Yes.
I'm going to translate the same. Yes. Fantanina nipetraka koa zany hoe ahoana ny fomba fiinstalena le plugin OpenStreetMap. Dia naverina tao le izy tsara ho mariny fotsiny fa ny plugin rehetra amin'ny QGIS dia gratuit avokoa, tsy misy andovana vola. Izy io dia ohatran'ny hoe extra kely packaging saina extra kely izay tsy misy ao anatin'ny GIS arakarak'izay ilaivanareo zavatra ilaivanareo azy. Ny option streetmap zao dia ny cliquer rehefa te hijery plugin ao amin'ny plugin eo ambony misy plugin dia Quick Map Services ny anaran'le plugin jerena dia installena na zao efa installé teo tsy installé tsony izy rehefa vao installé izay dia mandeha amin'ny web dia ino moa izy teo izay fa tsy tadidiko le option teo.
OSM standard.
OSM. Dia izay dia miseho eo ny ohatran'ny kazona bazina carte izy ity raha tsara raha fahazahoako anazy misy ligne be da be misy ny boundaries sy ny rehetrarehetra tsara ny OSM. I think that's it.
Okay, thank you. All right, the next thing that I want to show you based on a question that I got about reprojecting data. And so we had talked last time that all of the data has some type of projection. If we want to find out what projection we are in or what projection each of the layers is in, if you remember, you can come up here to the layer of interest, right click on it, go down to properties. The property window will pull up. And then in information, on the information tab, we can go down here to where it says CRS. And CRS stands for Coordinate Reference System, which is essentially the same thing as a projection. And it tells you here what projection this is in, or the Coordinate Reference System. This is in WGS 84, which is a geographic projection system, meaning that typically geographic projection systems have degrees, they're in degrees. They are really useful for displaying data anywhere on the world. They're not really useful when calculating distances or areas though. When you're calculating distances or areas, and somebody asked about this, and that's why I'm kind of going in that direction. You'll want to use a different projection system, specifically probably a UTM projection system. And this is actually the projection system that one can use for Madagascar, WGS 84, UTM zone 38S. And this is in a projected coordinate system. It's no longer in a geographic. And I know that's a little confusing, but it's basically what it is now the units are in meters instead of degrees. So if you want to calculate the area of something, you typically want to calculate it in squared meters or squared kilometers. You don't want to calculate it in degrees. That's a bit of an odd unit to use for area calculations or distance calculations. And so if you are using any of these layers to do that kind of a calculation, you'll want to reproject the data into one of these projected data systems. And this is the projection system, one of the projection systems that's been set up and useful for Madagascar. So when I reproject here in a minute, I'm actually going to reproject into this projection here. All right, I'm going to stop there before I actually do the projection and let Seheno explain what I've shared so far.
Thank you so much. We are here, the problem of about projections, right, guys? Io le problema foana rehefa manao an'le projection, nakaiza le données atao ahoana ty données ty fa nakaria anaty ranomasina tary le varika. De mila mamadika zany, nisy fanontaniana anankiray hoe mahoana ny fikalkulena le surface-na territoire de mahazo zavatra en degré nefa antsika icalculer surface tokony en mètre carré na en kilomètre carré. De dikan'izay tsy maintsy ovaina lay projection. Le fahitana le projection teo efa hitantsika tsara, mbola tsy ametraka an'le fanontaniana aloha, mbola io le izy le CRS io de io le projection any Madagascar. De andeha hanoro atsika amin'izay zany i mafio hoe ahoana no anovana an'ilay projection. De manara tsara ary avy eo misy no hitraduire anazy zaho ametraka fanontaniana kely indray avy eo. Zay raha misy fa tsy mazava de tonga de soratana ao amin'ny chat. Thank you.
All right, thank you, Seheno. Okay, so now what I'm actually going to do is, as someone asked about reprojecting data, and then someone also asked about minimum bounding geometry. So we're going to kind of combine those in a stepwise process to look at that. So let's look at our Silky Sifaka occurrence data that we have here. So I'm going to go ahead and right click on that, click on properties. And we just want to come up and see that it is in a geographic projection system. So it's just WGS 84. There's no UTM here. And the reason I know that also is because it's in degrees. Now I want to change this into a different projection that will give me meters instead of degrees. So technically I'm projecting this data into what's called a planar system. Again, I know this is a lot of new terminology, but the key here is that these geographic systems are in degrees, and UTM and other types of projections will give you meters, which are more helpful for area and distance calculations. So the first thing I'm going to do, we're going to finally be able to use one of our tools in our toolbox. And this search up here in the toolbox is really helpful. So it can actually, if I type in the word project up here, it actually gives me a bunch of suggestions. And this is really the tool I want to use, is I want to reproject a layer. So if I double click on that, a menu pops up and it says, okay, which layer would you like to reproject? Well, I can choose between several. And the one I decided I wanted to reproject was the Silky Sifaka occurrence points. It tells me essentially what its projection system is here, 4326. That's a code for WGS 84. And then it says, what's your target coordinate system? Well, I don't want to leave it in the same. I actually want to change the projection that it's in to something, again, that's in meters. So I can click on this over here, this little button which says, please select the coordinate reference system that you would like to project it to. So I'm going to go ahead and click on that button. Now there are literally hundreds, if not thousands, of different projections for the world. So I'm going to type up here to search for the projection that I'm interested in. I'm interested in WGS 84 UTM zone 38S, which has been designed specifically for this area of the world. So you can see right now, it gives me a little drawing of the world, and it shows this little rectangle shows me where this projection system is going to be the most useful. And you can see that in general, that covers large part of Madagascar. I could actually go to 39 potentially and see, you know, maybe I should use UTM zone 39S, since that covers this northeastern corner of Madagascar a little bit better. And that's the area here that I'm actually working with data on my map. So I'm going to go ahead and do that. I'm going to use UTM zone 39S, which includes that small area of Madagascar. So I'm going to go ahead and do that. Okay, now this here is saying, do you want to save this file permanently? So last time, remember I talked about that when you add data to the GIS program, it adds it as a temporary layer. And if you don't save it permanently, the next time that you open your project, it'll be deleted. So you can leave it as a temporary layer if you'd like to, that's fine, and then save it permanently next time. Or we can go ahead and save the file permanently. And by clicking on this menu little button here. Okay, and now it's going to pull up brought me to a place that I've been working on, actually the American crocodile. Right, so this is actually where I want to go. I want to go back to Madagascar seminars, QGIS. We're going to put it in our vector folder here, Lemur occurrences. And now I have to think of a name. And so I think probably the name that I had before, but I'm going to put UTM 39S, just so that way within the name of the file, I know now that this data is projected in a planner system of meters. Okay, so now we can go ahead and run this. We can click run, and what it's doing is it's essentially reprojecting the layer. And here's the layer here that we just created. So if we turn off that layer, we turn off the points, you can see these are the original points down below that are in the old projection system. These are the points in the new projection system, and they're basically in the same place, and that's a good thing. You want them to be in the same place. The only difference is that these are now, if we right click, go to properties, view the information over here, you can see now if we look at the CRS, it's in a UTM zone 39S projected, and our units are now in meters instead of decimal degrees. All right, I'm going to stop there. Sahana?
Alefa ndray misa. Sady ametraka fanontaniana manko. Aleo alefa dia sady ametraka fanontaniana ary vetivety dia manampy ndray avy eo. Eny ary. Dia nalefa ny mafio le namadika an'le projection teo, sady mametraka fanontaniana araka ny ohatrany tamin'ny heriny no sady mitraduire an'le zavatra noteneniny. Rehefa namadika an'le projection dia mijery ary amin'le propriété tsy aloha izy an'ilay ohatra zao mijery izy an'le sifaka propriété QGIS dia mijery an'le propriété izy mijery an'le projection. Dia inona no jerena ahafantarana hoe ahafantarana le projection fantatra fa inona no jerena, misy zavatra tokony jerena zay ahafantarana hoe tena WG 84 marina io satria inona ny zavatra nijereny teo. Zay zany dia mba varilo kely eo amin'ny chat eo. Dia rehefa avy eo izy nandeha nitape atsy amin'ilay processing toolbox misy barre d'outils io dia nitapeny fotsiny io mbola nitapeny io zao le izy hoe project. Dia mila avadika le projection, mila avadika dia le reproject layer io no najerevany teo. CRS le projection fa inona no tena ahafantarana fa tena io marina ny zavatra hoe ity ozy izy verifio tsara. hoe en inona ty zavatra ty de inona le izy teo. Ye, voilà, très bien, le unité le an'le izy. En décimal degré le izy raha ohatra le WGS 84. Fa raha le UTM le izy de inona le unité? De efa eo amin'ny chat ihany izay fantaniko izay de manohy ihany ahako. Oui, très bien. De manohy ahako amin'le layers de nanao izy hoe inona mila ovaina zany le projection de iny zany tadidina moa zany rehefa hoe manaraka logika hoe WGS 84 UTM zone 38S de tsy nanao le 38S izy fa rehefa jerevana nisy nijerevana teo de nataony 39S le izy. Inona koa zavatra anankiray ozy izy tsy maintsy tandremana mba hatao satria avy eo tsy hita ilay fichier tokony enregistrena le izy. Zay zany tokony enregistrena foana le fichier de nareo no mandamina mila fandaminana be le resaka fichier angamba tsy diso asa ahoana moa misy. Inona no adiniko?
Angambana manakapobeany zay le projection fotsiny zany le misy hoe géographique iny rehefa te hoe aiza amin'ny place-ny eto amin'izao tontolo izao place-na point anankiray ohatra hoe aiza amin'ny eto Madagasikara misy an'ity sifaka ity. Fa raha ohatra nareo nisy fanontaniana hoe ahoana micalculer surface de inona moa form range de le tsaratsara le UTM satria iny l'unité any mètre rehefa calcule surface sy distance.
Okay. Thank you everyone. Très bien. Great.
All right, great, thank you. Okay, the next thing we're going to do, again, and these are all based on questions that folks have already asked about, is we're going to create a minimum convex polygon around the points. And to do this, I'm just going to turn off some of these layers so that way it's a little bit easier to look at. Okay, so let's just look at these silky Safaka records that we have here, occurrence data on the landscape. And what if we wanted to build essentially a polygon that enclosed all of these points? So we just want the polygon to basically go around the edges of all of these points. That's what's called a minimum convex polygon. So I'm going to go ahead and create that here for you. And you'll be able to get a sense of what that looks like. So it's called here, and again, I'm typing and it's already popping up with what I want. And it's called minimum bounding geometry. So let's go ahead and do that, and you'll get an idea for how this works. So the first thing is we need to tell it what point file or vector file we want to use to build a minimum convex polygon. So this is the one that I want to use. I want to use the silky Safaka layer that we projected. Okay, this field here, I don't think you don't really need to worry about right now. This is basically if your data has different types of classes or groupings, you can build the minimum convex polygons according to those groupings or classes. We're not going to do that right now. And down here is where we select the geometry type. So what kind of a bounding rectangle or polygon do you want to build around this data? So a minimum convex hull is going to be that. So it's just labeled as convex hull. And then finally, we have this. Do you want to create a temporary layer or do you want to save the layer? So I'm going to go ahead and save the layer by clicking on that and clicking save to file. And I'm actually going to leave it in the Lemur occurrences a file. And this is, we're going to call this, we'll just keep adding on to this. So this is the name of the file. I'm going to call it Silky Safaka GBIF occurrence UTM 39S. And I'm going to call it an MCP. And MCP for me stands for minimum convex polygon. So instead of typing all that out, I'm just abbreviating it. And again, you can name these whatever you would like. It's just, this is kind of my coding so that way I know what that file is. So I click save. And I think we're all set. I'm going to go ahead and click run. And now, I close this. You can see that I have a minimum convex polygon that's been created, basically that touches each one of those points. So it's now the next thing that someone had asked about well, maybe I'll stop there. Let's summarize, and then we'll talk about calculating areas.
Misa, go ahead. It's a bit complicated.
I'll go ahead and pull up this menu for you. So
yes, it is a little bit complicated. How to explain that? Raha ohatra te hanao polygon nareo ka mikitika ny point rehetra tsirairan'le tsy fantatra ny buen'izy ity. Matthew, I want to ask a question. What's the purpose of the minimum convex polygon? Maybe to find where the area the silky sifaka are, or what's the purpose, the aim of that?
So the purpose might be, let's say that, you had a bunch of points through here. I mean, we have some, but maybe you want to select the area where you want to do a field study, or you might want to protect an area. I mean, this is a really simple method. There are much more complicated methods, but that's typically why someone runs a minimum convex polygon, is they're delineating a study area for the species and saying all of the occurrences fall within this area. So this is the area that I need to focus on for whatever purposes. Is that helpful?
Yeah. Thank you. Yeah. Ny teneniny teo moa zany hoe ny tena buan'le minimum convex polygon na za raha mbola tsy de nampiasa loatra n'izy ity teo aloha. Raha ohatra zany nareo andeha terrain de hoe aiza amin'ity ala ngeza be ity zany za no tena hoe andeha hiasa, de ilainy reny raha efa misy point n'olona tany aloha tany ohatra ve misy hoe tany misy occurrence ana lemurien anankiray, de te delimiter zone ngezangeza anankiray zany nareo, te delimiter zone fotsiny anankiray nareo anatin'le angeza be de ao amin'ny barre d'outil foana ihany ahitanareo anazy minimum bounding geometry. Ohatra mbola tsy niverifeko inona izay amin'ny teny frantsay, de ohatrany rehetrarehetra ihany iza ny couche tianareo anatin'ny couche inona ny misy an'le point tianareo lalaovina anaovana an'izay delimiter an'izay polygone zay de nampidiriny le couche tianareo sauvena, tianareo atao permanent ve le couche hoe sauvena amin'izay manaraka tsy mila manao le asa indray mandeha indray le hoe is create temporary layer sa temporary article.
Ye, misaotra misy le izy teo zany ny tena ny buan'le izy zany de zay tena misy zay teo hoe le delimiter an'ilay toerana misy an'ilay ohatra hoe lemurien varika tianareo hoe aiza daholo le izy ananana zany le point, fa tsy ananana tsara le surface territoire misy anazy, de zay no ijerevana an'le minimum convex polygone. De le outil na le fitaovana ampiasaina de le minimum bounding geometry io de ny cliquer, ohatra nisy ny fotoana mafio teo ny cliquer an'ilay hoe inona le jerena le izy de zay no antony. Sorry Matthew, can you just repeat again the minimum bounding geometry, please?
Repeat what specifically about it?
Yeah, when you click, there are some choices about what to choose when you want to calculate the area here.
So
geometry type, yeah.
So typically use the convex hull, but there are other options. So this is a rectangle around the point, so it'll create a rectangle. And so, these are different options that you can take a look at and see which ones might work best for you. The one that's most typically used is the convex hull, and that's why we chose that one.
Okay, yeah, thank you. Yeah, samana tatsy daholo miara-mianatra tsika, misaotra betsaka rindra, naraka tsara daholo. Mahay indray ny mpianatra ato noho ny mpampianatra maty. Yeah, thank you.
All right, thank you all. the next thing that can be really helpful here that I just want to, this is kind of an add-on. No one asked this question, but I think it's something to be aware of here. If we look at this minimum convex polygon, and let's zoom into this point up here. Do you see how the vertex of the polygon ends right at the point? So if there was actually a silky sifaka recorded at this site, it's very likely this animal is moving around in a larger area, right? It's probably not only occurring at this point in areas this direction within the polygon. So one thing that we can do to, I'm going to go ahead and zoom to layer just so that way we can see this a little bit better. So one thing that you can do, go ahead, let's zoom out just a tad. There we go. Okay, so one thing that we can do is we can actually buffer this feature by a little bit. So that way we can account for the fact that these animals probably are moving around. So I can type in buffer here. And if I double click on buffer, it's going to ask me what I want to buffer. So I want to buffer the file that I just created here. It's going to ask me what kind of distance would I want to buffer by. And I'm actually going to buffer by 10, but let's do 10 kilometers. 10 meters seems very small. Segments you don't usually have to worry about. It's not, and so I'm just going to go ahead and run this as a temporary layer. So that way you guys can get a sense of what it looks like. So I went ahead and ran that. And so now you can see, I'm going to go ahead and move my layer down. So now you can see basically what we created is here's the original minimum convex polygon in gray. And this is the minimum convex polygon that I have now buffered by 10 kilometers. So you can see that's something you might want to consider doing because you may not want the very edge of your polygon to occur where the points are. You may want to buffer it by a little bit. All right, so Heno?
Yeah, thank you. Ny hitantsika teo angambany le resaka buffer teo io nazavainy liny io dikan'le hoe buffer raha m'étendre kely an'ilay toerana tiatsika atao de nindrindako mahafinaritra am'le QGIS de ohatrany tapena fotsiny le toolbox le terme zany mety hoe mila tadidina fa hoe buffer de mitotry ny clic buffer fotsiny izy de mipoitra le izy de novana lay unité an'le distance anaovana anazy. Hitako hoe somary plus ou moins logique sarotra le izy fa manomboka rehefa tafiditra anatin'le logika zany de mety mora ihany le izy raha misy fanontaniana de aza misalasala efa nomboka mety anao zavatra hafa amin'izay tsika izao.
Ie, tanjony anapiky kely fotsiny ngamba hoe tanjon'le izy ohatra hoe amin'io point io tsy mipetraka mandrakizay dorio amin'io point io le sifaka fa mihetsiketsika izy mandehandeha mitazakafo de midelimite zone anankiray nareo mba tsy ho juste be zany le stade anareo de hoe mety hoe mbola misaka kely makariva izy sa makariva. Amin'ny rehefa parc koa ohatra misy zay resaka buffer zay amin'ny parc national sy ny tariny regny.
Okay.
All right, thank you, Sehano. Okay, now the next thing that we're going to do is we're going to actually look at the area of each of these. Now, QGIS makes this pretty simple because it already automatically calculates the areas for these. So if I go into my, oh, hang on a sec, if I go into my original minimum convex polygon that I drew, and I right click on it over here, and I go over to open attribute table, it actually already calculates the area and the perimeter for me this is in square meters. So this is the area in square meters, which, can be helpful, but it may also, I use this a lot. Google to help me convert. And so it tells me that I'm actually going to reverse this. I'm sure you guys, hopefully you guys have used this before. Come on here. See, there we go. So it says that 1 square kilometer is equal to 1 times 10 to the 6 square meters. So if I want to actually determine what this is in square meters over here, I would take this number, right, and divide it by 1 plus 10 zeros, and that would give me the area, which essentially, I said 10 zeros, I'm sorry, I meant 6 zeros. So that would essentially move this decimal point over 6 places, 1, 2, 3, 4, 5, 6. So this would tell me that this is 4,442.8 square kilometers in size. How did I know this was in meters? I should have asked that question. How do I know this is in meters and not in kilometers? I'm sorry if that was. The reason that I know that's in square meters is because if I go back and I look at the layer's properties, it tells me right here what units it's in. It's in meters. So when it calculates the area, oh, it's not going to let me do that while I've got that open. So when I calculate the area here, I know that this is in square meters because the projection is in meters. So this is square meters. And then I just simply did a Google translation to say, well, how many square kilometers or how many square meters equals 1 square kilometer in order to be able to convert that in my mind, at least, and I could write it down in square kilometers. Okay. Questions? Well, I shouldn't say questions. Ahead, no.
Yeah.
Go ahead.
Yeah. Yeah. Misa?
Yeah, yes. Le izy ohatra ny tena zava-dehibe teo angamba ny mahafinaritra be ny QGIS tonga de calculenao anao ny surface ana ina moa ana couche anankiray raha tianao tonga de calculenao zany fa tsy hoe raha tianao. De ao amin'ny propriété an'le couche le izy de ao amin'ny table attributaire sika. Table attributaire le izy amin'ny teny frantsay ho an'izay manana QGIS amin'ny teny français de tonga de misy hoe surface eo fa ilay unité fotsiny no satria mètre ny unité antsika tany amin'ny tany le propriété an'le couche de en mètre carré zany ny surface. De nataony teo moa zany nanao nijery tamin'ny Google izy hoe firy mètre carré, firy kilomètre carré ny 1 mètre carré sa ny anarany akamoko ndraindray tonga de le copie-coller na Google conversion 2000 firy kilomètre carré. Zay fa mahafinaritra le QGIS. Resaka surface le izy.
De tonga de voavaly zao zany ny fantaniana hoe am'le hoe ahoana ny calculena le izy tonga de mijery eo amin'ny table attributaire fotsiny zany de mipoitra zany le izy. Yeah. Okay, thank you.
All right, thank you, Sahana. Now I want to take a bit of a deeper dive in calculating areas because we got lucky and it showed us what the area was automatically. But what happens if that isn't the case? Or you get a file and you don't, there isn't an area column here and you still want to calculate the area. If that's the case, what you can do is you can come up to this open field calculator button up here in the attribute table. Click on that. And what it's going to do is it's going to say, all right, would you like to create a new field? And I'm going to say, yes, I want to create a new field. What is the field going to be named? I'm going to call it area. Well, I can't quite. Area calculation essentially is abbreviated. So I'm going to call it area calculation. What do I want this field to be in? What type of units? I think decimals is best since we're calculating area. And now you have a variety of different types of calculations that you can do. So each one of these has, and obviously I can't go through all of this today, but this is all kinds of different essential calculations you can do. Now, the one we're interested in is geometry, and it's this $ area. Now, each one, if you click on it, it gives you a little description over here in the right-hand side about what it's doing. And so this one is simply just calculating the area of, there we go. I double-clicked on this, and now it shows up over here. So basically, I'm telling it, I want you to calculate the area of all the polygons. There's only one polygon in this case, and put it in a new field that's called area cal. And please use decimals when calculating, essentially. So now I'm going to hit OK. And what you can see is that it's actually placed a new field here that's called area cal that has a very similar number. The number is a little bit different. And I have to admit, I am not sure why QGIS does this, because the file hasn't changed. But for some reason, when you calculate the area manually, you get a slightly different answer than when it calculates it automatically. And that actually is concerning to me. And I have not received an explanation as to why this is occurring, why this is slightly different than this. And so that's something I need to investigate further. But this gives you at least a rough estimate of what the area is for that polygon. All right, Seheno, I'll let you go ahead and translate.
Yeah, thank you. Yeah. De rehefa nitentsika hoe micalculer le QGIS dia kay tsy micalculer indray. De ahoana indray ny atao rehefa tsy micalculer izy de tsika indray zany manao an'le calcul. De misy icône maromaro eo ambonin'le ao anatin'le table attributaire io de misy an'le calculer le opiny io amin'ny teny anglisy io fa zay mety amin'ny teny frantsay ny aminareo any champ angamba raha tsy diso le field de mila micalculer an'izay de sokafana iny de micréer na manao champ vaovao de inona tsara le tsy maintsy jerena tsara teo izy le fantaniana manko de apetrao amin'ny chat ny valiny rehefa le manao an'le output mametraka an'le anarana koa zany conseiller ko atao zavatra logika tsara de ina le zavatra tsy maintsy jerevana tsara ery ambany ina le type an'le output field type teo no nataony ina le izy teo misy maromaro izy de ina tsy maintsy safidina de mba soaty kely ao amin'ny chat de aveo satria area no calculena de jerevana anatin'le géométrie misy zavatra maromaro io zany. Izy zany zay zavatra rehetra le manipulation rehetrarehetra satria omena le vidéo mijerina reo de maharaka an'izay rehefa tonga any manko de hoe nisy zavatra tsy tadidina zavatra tsy nety de mamerina indray. De zay ny zavatra nyteneniny teo koa hoe tsy hitanareo fa rehefa vita le calcul zao de tsy mitovy nefany zavatra anankiray ihany io de somary mahagaga ihany manko tsy mampitovy andreo. Mbola tsy fantatra tsara ny anton'izay fa anisan'ny zavatra tediaviny mafio zay de mety hanome fanazavana izy any aoriana kely ihany. Iza namaly tamin'ny chat tato. Ransa ihany. Sotro, Thank you.
Thank you. Okay. All right, so now what I want to show you one last thing, and then we're going to talk about kernel density estimation, which was another question that we had. But I want to show one last thing here about reprojections that I forgot earlier on. So what I showed you when I showed you reprojecting a layer, this only applies to vector data. This doesn't apply to raster data. So you can't use this tool to reproject a raster. And in order to reproject a raster, you actually have to use this warp tool. It works functionally the same way, but it's only for rasters. So here, if we're using the warp tool, we come down and we select the raster that we're interested in. So I might want to reproject that forest cover data. The source CRS it's asking you for what is the projection already in. The program actually already knows what projection it's in. So typically you leave this blank. The only reason you would fill this in is if there was no projection associated with this. So it already says this is your projection, is 3273.8, which is actually it's WGS 84 UTM zone 38S. And this is the code for that. So it already knows what projection it's in. So you don't need to put in a source CRS. The only reason you need to do this is if it didn't know what this projection was. But now we put in the target projection. So what do we want to project it to? And we could project it into just WGS 84, which is a decimal degree projection again. And then now whenever you project a raster, it's going to ask you for a resampling technique. And this is basically because we talked about last time that rasters are made up of pixels that contain information. And when it reprojects, it essentially has to recreate all of those pixels again, all of those grid cells again, and provide the data in that new grid cell. And so it's asking you, how do I recreate these pixels in this new projection, this new CRS? And you have a variety of options: nearest neighbor, bilinear, cubic, cubic spline, and it goes on and on. This is you can read up on all of these if you'd like to, but my general recommendation is if you have categorical data where data fits into different bins, right? It's either a 1, a 2, or a 3. It's group 1, group 2, group 3. It's, it's very, that's when I talk about categorical data, I'm talking about data that is, it's very discrete. Everything has to fit in one category or another. Nearest neighbor is the best approach for categorical data. Now, bilinear and cubic are better approaches for what is called continuous data. And continuous data are data that do not fit into nice little categories, but they have, you could have 5.723, and then you could have 5.923, and then you could have 10.1, and then 121.5. Your data could be in anywhere. It doesn't have to fit in any nice little bins. So the forest cover data that we looked at last time, I would consider that continuous data, primarily because it's between 0 and 100, right, about how much forest cover there is. And so there's 100 different potential numbers that are different values. That's the word I'm looking for, I'm sorry. 100 different values the data can have. And so that's really more than what I would consider for continuous data. Categorical data. Categorical data is typically you have about 10 or no more than 20 different options. So I'm going to select bilinear, which is going to be the best method for resampling continuous data. And the rest of this, we don't have to really worry about. It's all optional. And then I can go ahead and click run. And what it's going to do now is it's going to reproject my raster into my new coordinate system that I selected, which is the WGS 84. And so it's going to take a little while to do this because it's actually a pretty big file. Seheno?
Yeah, go ahead, Miss Anda. Then I will.
Yes,
I will add.
I'm going to translate the first part, then Sen will continue. Le reproject layer natohony Mathieu teo tamin'ny voalohany teo ho an'ny ho an'ny vecteur ihany. Fa ahoana kosa ny atao raha ohatra ka raster ny kosotsika, dia io moa zany ao amin'le outil ihany warp reproject no safidiny. Can you please Matthew, can you please display the word?
Parameters.
Yeah, sorry. Oh, it doesn't allow you. It's okay.
There we go.
Okay, thank you. De inona le couche safidianareo tianareo asina atao reprojectena de misafidinareo le forest 2014 io nentsika zany couche raster. De le source rehetra io ny matetika ny couche rehetra na efa misy projection avokoa matetika. Tsy kitihanareo mihitsy zany io raha tsy hoe tsy misy projection ilay couche zay nampidirinareo. Avy eo amin'izay hoe inona ny projection tianareo projetena, inona le système de coordonnées tianareo avadika amin'ilay izy dia eo amin'ilay target CRS eo no apetakareo WGS 84 zao safiditsika teo. Sy no angamba navelako anazavan'le resaka resampling.
Le resaka sotra misy le resaka resampling teo arakaraky le données raha ny fahazahoako ny teny mafy teo. Ny données misy données karazany anankiroa zao ny hainiko teneniny teo hoe données catégorielles na données continues. Raha données catégorielles zany hoe anatina catégorie hoe ty zavatra ty na ohatra hoe 1 0 1 0 2 1 2 ohatray zany misy données zany anatin'le raster zany na fahazahoako anazy de rehefa misy anatina catégorie mipetraka anatina catégorie fa tsy hoe 0 1 2 3 4 zay zany continue zay zavatra zay fa ny catégorielle tena manaraka hoe zay données anankiray de anatin'ny ty catégorie iray ty ihany. De raha vao zay ozy izy de ny zavatra conseilleny le ao amin'le resampling to use io de le plus proche voisin ngamba zay no fanazavana raha tsy diso misy le nearest neighbor, les plus proches voisins no alaina fa raha données hoe continue hoe anatina hoe 0 1 2 3 4 continue zany zavatra zay tsy mipetraka anatina catégorie fa continue ohatran'izay le izy de teneniny hoe le linéaire inona ny dikan'io amin'ny teny frantsay bilinéaire io ki double linéaire ohatran'izay. Fa zay zany afaka mametraka amin'ny chat zay afaka zay manampy antsika miara-mianatra de eo manomboka le terme koa be da be no zay tena hay tsara amin'ny teny frantsay vao mainka moa zany teny gasy tsika tsy manana. Zay mbola manana fantanina amin'izay de araroty ihany mametraka anazy eo amin'ny chat Yes, okay. Thank you.
All right, thank you, Sahana.
Thank you, Matthew.
All right, let's go ahead and, all right, so I'm going to put this aside while this is still running. And we're going to talk next about kernel density estimation, since we had a question about that. So one thing I'm going to do here, I'm going to go ahead and just kind of move this out of the way. Okay, I'm going to turn off some of these layers that I've had on. Okay. So again, let's look at our Silky Safaka points that we have here, occurrence data. There's a couple different ways that you can create a kernel density surface. And essentially what a kernel density surface or estimation surface is it's going to show the density of the points on the landscape. So it's going to have different values for where you have very dense points versus areas where your points are more spread out. So the first thing I'm going to do is I'm going to show you how to display a kernel density function without creating one. And then I'll actually show you how to create one as well. So the first thing that we can do here is perfect. Okay, so that completed. So my new, and it looks like it's loading it. There we go. So that is now my forest raster layer that has been reprojected into, excuse me, here it is right here, into the WGS 84, just to follow up on that. Sorry to change gears here. But you can see this is it's named Reprojected because I didn't give it a name. It's a temporary file, but now it's in degrees instead of meters because I reprojected it to WGS 84. All right, I'm gonna go ahead and turn that off. And let's talk again about the kernel density estimator. So if we come in here, we right click on the layer that we're interested in, go to properties. We'll move this over here. If we go to symbology, and up here, there's a menu that says single symbol. We can go down, we can click the down arrow and we get a menu, and we could click heat map. Now, essentially a heat map is the same thing as a kernel density estimator, but we're actually not creating the layer here. We're just telling it to display the data in that manner. So what I want to do is I actually want to give it kind of a red ramp. So areas that are very dense, have a lot of points, are going to have this dark color. Areas that don't have a lot of points are going to have this lighter cover. I have to provide it with a radius. In other words, it needs to be considering how far away do I look from each point, and consider other neighbors. And so if I typically I want to use map units, and let's do 10 kilometers. I think this will go ahead and create something. If I click apply, let's see what we get. Nope, that wasn't good. The reason being is because, oh, I think I know what I did wrong. Let me double check something here and see what I get if I type in. There we go. Okay, so my apologies. Map units, when I told it to use map units, essentially I'm telling it to use the units that the map is in. The map is in, if we look down here at the bottom of the screen, it says the map is in EPSG 4326. And if we remember what this stands for WGS 84. I know that's a lot to remember. WGS 84 is in degrees. So this radius that I'm telling it here to map by is in degrees when I say, please map it in map units. So I just told it to map by 1/4 of a degree. If I want to go to something a little bit smaller and click apply, you can see that this density estimate changes. If we go up to, we want a radius of 1 degree, that blob gets bigger. So this is something you would have to play around with. But this is just a way to get a density estimator based on those points using just the symbology tab. Not really helpful. So I'm going to go ahead and change this back to points. And instead of what I'm going to do over here is I'm going to, I'm going to turn in, I'm going to use this tool called kernel density estimation or heat map. And if I double click on this tool, what it'll do is I'll actually create a new layer. I'm going to create a raster layer that's going to show me that heat map or that kernel density estimates. So if I come up here, I select the layer I'm interested in. It's already selected the one that I am interested in right here. Silky Safaka GBIF occurrence UTM 39S. I have to select my radius. Now what's nice here with this is I can actually select the radius, the distance that I'm calculating this over, in the units of my layer. So I'm not stuck with the units of the map, which the map again is in WGS 84, which is decimal degrees. The units of this are in meters because it's a UTM, right? A UTM projection. So how many meters do I want to use? Or I could convert it to kilometers if I wanted to. So let's do that. Let's just do a very simple, let's do 10 kilometers just to see what that looks like. So I want to do a heat map that uses a 10-kilometer radius. So in other words, it goes out from each of these points 10 kilometers and then sweeps through and sees how many neighbors it has and uses that to calculate how dense to make that each of those pixels, how it increases the value of the pixels based on the number of neighbors that it has. So let's just pick a density, or excuse me, a radius of 10. The next thing it's going to ask me is how many rows of pixels do I want when I create this? So this is saying, go out 10 kilometers, count all of the neighbors you have, and use that to estimate your value. But then how big do you want each of your little grid cells or pixels to be within this area where all the points occur? And so, you know, maybe I want to have 300 rows, and it'll automatically update the columns for me because it's going to create essentially a heat map. I'm sorry, I keep clicking on the map by accident. It's going to create a heat map that's going to encapsulate this whole area. So we can go ahead and take a look and see what this looks like. It may not be what you want. Okay, it's not terrible. So we've basically created a heat map, and you can see the highest values are occurring here in the white, and that's because that's where most of your points are. Now, you know, maybe that's not really what you wanted. You know, maybe you wanted, you can go back to the parameter tab. Maybe you wanted to look, this is really a trial and error type of approach. So let's do 50 kilometers. You know, maybe, I think the number of pixels looks pretty good. And let's go ahead and run that. Okay, so now I'm sweeping out further. I went out 50 kilometers from each of these points. And so now this is the heat map that I get. And you can see that if we go back underneath here, let me turn that off. Again, the area that's showing the highest values is right here, which makes sense because that's where most of the points are. These other points down here are pretty outliers. They don't have any neighbors. So that's why this value is coming in really strongly. And so you can obviously, this is something you kind of have to play with. There's not a correct answer. It really depends on what your interests are. How large do you want to make your radius? How do you want to calculate, you know, how much of an area do you want to calculate where your neighbors are? And then how many rows and columns do you want to have within your heat map output? And again, these are outputted in raster format. You can always go in here and say, I know you don't necessarily need to cover this when you, but I'm just going to demo. You can always come in here and change the way these heat maps look, right? Right now it's giving it to me in black and white. Maybe I don't want to make it black and white. Maybe I want to come in here and actually change it to a pseudo color. Oh, I'm sorry, that's up here. Single band pseudo color. And now it should, I'm sorry. I don't know what happened here. Why did it, I apologize. I'm not sure why it disappeared on me like that. Let me try a different. So normally within here, there we go. Maybe it'll work now. There we go. Okay. I'm sorry about that. So we can always go in here. We can change the colors of this if we want it to be, you know, we don't want it to be black and white, but we want it to have other colors as well. So hopefully this gives you some introduction to heat map or kernel density functions. And then, of course, each of these points has a very different value. And we can determine that by, if you remember this tool from last time, the information tool, we can actually click on this and go to where it says heat map. I'm going to go ahead and turn off some of these other layers just so that way it makes it a little bit easier. Here's the values of each one of those, 51. And you can see these values are a lot lower because there are a lot fewer neighbors, whereas this is where the bulk of your occurrences are happening. So that's why these values are higher here. All right, I know that was a lot to cover. I'm going to stop. Say hello. Let me know if you need any help translating or going over something again. I can't translate.
Yes, because before translating, I have to ask a question because what is the kernel density estimation, and why do we need to calculate something like that? Because you talked about neighbors and sorry, I'm
No, it's okay.
Yeah, okay. Before translating, I would like to understand the logic behind.
So I personally I never use them. So my understanding of uses for them is a bit limited, but I can tell you that it provides you with an estimate of the density across the landscape. So the density of points. So if someone, it works, it's actually used a lot in like crime maps when they want to see which areas across the landscape are hotspots for crime or other types of activities. So if you've got a lot of points, it's not really useful here because we have very few points. But if you have thousands of points across your landscape, and it's just a lot of information to look at, right? The heat map can be a way to make the information easier to look at, because what it'll do is it'll highlight specific areas for you about where you should go to, if you're talking about crime, to address that crime. Here, so what it might do is it might say, if we were interested, where are most of the Silky Sifaka records occurring? They're here in this area. Now, we really don't need to generate a heat map to tell us that, because we can just look at the occurrences. Oops, I'm sorry. I've got too many layers here. There we go. We can just look at the occurrences and we can tell, right, that most of the Silky Sifaka points are here. So this is probably where we want to go if we want to see one or conserve habitat. But if you had, imagine thousands of points across the landscape, it might be really hard to tell where's the best places, where are all those points clustering. And so that's why you would use a heat map to help you locate where the points are clustering on the landscape. Great question, Sahano. I wasn't clear about that. Is that helpful?
Yeah. Yes. Thank you. Thank you so much. Yeah.
I think we use it. I think we use it with deforestation and fire as well. If I'm not wrong. I've seen that before.
Ah, okay. Yes. So I would like also to ask who the person who asked this to share why you or why you use the kernel density estimation. So if you can just put in the chat so we can all understand. Yeah, de azaveko kely ny tena za zany ny aleoko manko manontanytany foana toy izay manao foana de manazava zavatra diso. De za mbola tsy nampiasa mihitsy an'le kernel densité, le estimation ana kernel density zany filazantsika anazy angamba de to de atao teny frantsay hafahafa be. Fa rehefa nantaniko tsara le izy teo raha ahoana ny fahazahoantsika anazy teo de hoe fahafantarana raha manana point be da be, tsy de mipetraka eto loatra le izy satria le point le silky sifaka vitsivitsy. Fa raha ohatra hoe manana point be da be hoe aminao manarivony zany le point am'le toerana andehananao, de te hamantatra anao hoe aiza tsara ny tena andeha araka ny teny misy teo, ohatra hoe aiza ny tena misy an'ilay forêt dégradée na déforestation de tena hojerevana hoe inona zavatra mitrango eo, mety hoe zany de isafidy an'ilay toerana iasana ohatra zany. De izay zany ny antony hikalkulena izy ity. De le manipulation be da be teo io mbola veriny masule teo le izy mandray misy anankiroa zany le izy teo. Sady zany makaiza moa le anankiray hitako ato zao de le anareo le mitena le anankiray atao voalohany, fa le anankiray hitako teo de le hoe tapeny mihitsy le hoe kernel density estimation de mipotra lay io heat map io zany mipotra makaiza le anankiray teo mba soratikely eo amin'ny chat. De ny zavatra tena teneniny teo foana koa le resaka unité tandremana tsara foana. hoe ahoana tsara le unité teo zao izy ohatra nivadibadika kely fa teo mètre dia aveo kilomètre eto zao izy kilomètre l'izy eo amin'le rayon an'le izy teo dia aveo mijery tsara an'le output-n'le raster zany le resahantsika eto misy ny données vecteur misy ny données raster dia raster le resahantsika eto ya dia misy zavatra ovaina iny afaka averinareo jerena rehefa ho azonareo ty vidéo ty fa zay zany ny tena tanjo anatin'le izy somary novainy ihany koa lay sary le couleur andreo nahafahananao any ohatra ny violet sy ana io fa ny feverako zany rehefa haitsika fotsiny le logika ny hoe inona ny antony dia ahoana fanaovana anazy dia zay izy mety hazava kokoa. Inona mety anampiana misa?
Zay ihany angambany. Le couche lalao-tsiliky ty fotsiny ohatran'ny tsy raster fa le occurrence-na silikisifaka. Fa le tamin'ny voalohany le anona no raster.
Ok. Ay marina zany fa le zavatra mivoaka no raster. Zay? Ok. Yeah. Ok. Diso zany le occurrence jerevantsika dia hijery an'le densité teo dia mivoaka le izy dia manome an'io raster io. Zay le izy le misy
Zay.
Okay. Yeah. Okay, thank you.
Okay, thank you. I know there were also a couple. So this is the end of the questions that I received. There was a couple other questions that were asked that I wasn't quite sure what the question was. So if those folks wanted to ask them again, maybe I could do a better job of answering them. There was one question about remapping a point based on precision, and I'm not quite sure there's a couple different ways to remap a point, so I'm not quite sure what they are. One way to remap a point would be to delete this point and then redraw it at another location. I don't know if they're trying to get at creating buffers around points to account for uncertainty. So I'm just not sure what, I just need a bit more clarification on that question. The other question that I need a bit more clarification on what they're asking is, there was a question earlier in the chat about something about, let me double check. Up here that talks about, okay, the kernel density, that was fine, but there was a question about the minimum convex polygon that I didn't quite understand the question about whether the surface of the minimum convex polygon is the same as, here it is. Is there a difference between the surface of the polygon and the MCP surface? I'm not sure I understand that question. So anyways, so I'm stopping for the next few minutes, and any other questions that are out there or clarifications folks have.
Afaka mametraka manazava kokoa an'ilay fanontaniana angamba ny rato dia aveo Dominico afaka miteny ihany koa manana fanontaniana sady efa nanangan-tanana zao amin'izay fotoana ahafahana miresaka na atao amin'ny chat.
Sorry, hi everyone. Just a quick question. I don't know how to activate processing tools, Matthew.
Oh, how to activate your processing tools? Sure.
Yeah, sorry.
No, it's okay. Good question. So if you come up to view, you should come over to the panel here, and then you'll want to click on processing tools, and you should be able to view your panel at that point. So if I were to click on, if I were to turn it off, and I'm actually going to close this identify thing, so I have nothing over here, I can come over to view, panels, processing toolbox, click on that, and now you should end up with a toolbox over there. If you don't, then we may have a different problem with the program itself. Other questions?
Okay. Radu, do you want to explain a little more about your question?
Okay, of course. Can you hear me?
Yes, we
No?
can hear you.
My question is because if you use QGIS for calculating surface, you can calculate it directly with QGIS, and with MCP also you can calculate surface. So are they the same results or different? I think in MPC you can consider some of the data, but total of them, like 60% or 70%, sometimes 90%. Does it make sense? No.
Mm-hmm.
Yeah, I'm sorry. I think you were providing an alternate method, which is great. GIS has a number of, there's always more than one way to do the same task. So, but I couldn't hear what you were saying primarily because it was rather quiet on my end anyway. So I hope everybody else was able to hear that.
Mm-hmm. Aiza le ina le méthode anankiray Rado? Le calculena le izy?
No, one method is the use of QGIS for calculating area. Okay, for calculating area of forest site, for example, you can use QGIS for calculate how much kilometer square or meter square is it, and then with MCP as well, you can use it, but for their purpose. But I think they might be the same if you consider the percentage of coordinate as 100%. Azo mahita koa miteny aloha raha mety sarotra ianareo indray mandika azy. Ohatra hoe amin'ny MPC zany afaka considerena 100% point raisina dia mahita surface ianao amin'ny range
Ina le MPC azafady?
MCP le minimum convex polygon dia nampianarana teo. Okay? Dia raha raisina 100% ny point amin'iny dia afaka mahita ianao hoe tonga dia ao anatin' izao zany surface ahitana an'ilay vy tsy izy any sorana. Raha ohatra indray ianao ka mampiasa méthode QGIS tsoratra fotsiny manao calculana surface dia tonga dia raisina daholo koa ilay surface dia mahita surface koa ianao ka izay ny fanontaniako hoe mety hitovy avy sa mety misy mahasamihafa azy le avy amin'ilay MCP zany sy le hoe tonga dia manao calcul direct amin'ny QGIS an'ilay surface. Diako ray mandeha izy raha mety tsy azo
Okay. Yeah. So from my understanding, as you said, and Rad said also that, Matthew, there are different ways to calculate areas. So one way is to use the minimum convex polygon, and there is another way, as he said, just to calculate in QGIS. And he wanted to know if the methods, if they are different, we may got some different results or not.
So I believe it has to do with, and this is something I apologize, I don't have an answer for right now. But the reason that we got slightly different results, it has to do with I believe the issues in the projection. So it's calculating the areas slightly differently because of the differences in geometric versus planar. And I actually began to read about this last night because I was concerned this topic was going to come up, and it's not clear to me yet what is happening, like why we're getting slightly different areas between the two. And so that's something that I will continue to look into, and I can provide you all with an explanation about why those areas are in fact coming up a little bit differently between the two. And I think if we go into, let's go ahead and open that. And I'm not sure if this is, but I don't have a clear answer for you today, and I apologize again. So this area was calculated when we just created the MCP. So the program automatically calculated that area. And then I went in and actually calculated this area using the field calculator. And you can see they don't quite match, right? In square meters, there's a bit of a disconnect. And a big part of that has to do with the way that the area is being calculated. And there are different ways that the area is being calculated. And I need to dive in a little bit deeper and try to understand why these areas are being calculated differently with the same polygon. And again, it likely has to do with the projections that we're dealing with. And I don't have a good answer for you today, but I can get that for you. Does that address the question, Sahano, that was being asked? I mean,
Yeah,
I didn't answer it.
Yeah.
Yeah,
Okay.
thank you. Yeah, so Domenico,
I have
just ask
sorry.
question, yeah.
Matety mpiavoatra ny sotro kely. I try to do the processing tools, Matthew, but it's appears nothing for my. I use 3.10 version of QGIS. I don't know why it's not appear nothing.
Yeah. So are you
there is plugin to install or don't?
No. So did you successfully install QGIS and were you able to start it up like this?
Yeah.
But yet you don't have a processing tool?
Nothing in the layer.
So
do I have to put all the map and point and then activate the processing tools?
No, you don't have to. It should be there. So you've gone down to toolbars. Do you have anything here? Do you, or excuse me, on panels, do you have this?
Yes, yes.
And you click on it and this does not appear?
There is something appear, but no interpolations, something like that.
You don't have a search bar or anything here?
Yeah, nothing like this. Like you, like, yeah, nothing. I mean, it's like
it's so. One
empty.
thing you might want to consider doing is, uninstalling it and then reinstalling it again and seeing if there was some kind of an issue with the installation. It's also possible that it's a display problem within your computer. Unfortunately, it's really hard for me to be able to troubleshoot the issue without actually being able to be there. Do you have any colleagues in, where you're stationed that you can ask to help with this? And I apologize because it's hard for me to do a lot from where I am.
We can see that together, Domenico, if we meet maybe this week, next week.
And Sahano, was that you?
Yeah, I was going to say that because it's difficult I know there are many issues when setting up the software and something like that. Sometimes it's because maybe your internet connection is bad, so some things are not here. So yeah, I would suggest you to ask Misa or another colleague to do that, or as Matthew said, désinstaller, réinstaller. Okay.
Sahano, I'm happy to, at some point, if there are some people, to get online with you and that person, and to try to have them share their screen and we can try to work through it. It's hard. It's hard to do it remotely like this, and I'm not a software person, so if there's a software problem, I won't be able to necessarily solve that, but at least we can walk through their installation. We can see what's on their screen and we can select the various things. I'm happy to do that with them, if that's helpful.
Oh, okay, thank you, Matthew. Yeah, raha misy aminareo zany manana problème na misy zavatra tiana ho jerena précisément, zavatra plus approfondi kokoa, de afaka miaraka manao Zoom tsika, de nareo manao ny ina moa zany share screen de eo Matthew manazava hoe zao no tokony ataonao am'zao, zao no tokony ataonao am'zao. Mila fotoana kely zay fa afaka ataony tsara hozy izy de saorana be da be sady izy am'zay fandavan-teny zay. Thank you so much, Matthew. It would be very helpful for some of us.
Okay. I guess we're about at time, aren't we? So thank you everybody for your time. I appreciate it. Lucia, I don't know if you have anything to close out this particular training and how we would like to move forward at this point. But I think I need to wrap this up. I'm happy to still answer some questions. I'm going to get back to you guys on that area calculation, and I will write up an email and send it to Lucia, who can send it out to explain why those areas are not matching.
Lucia had to step out, but thank you all for coming, and we will, and thanks also for your interest in Global Forest Watch. So maybe we will think about doing another webinar in that.
Thank you all. Appreciate it.
Yeah, thank you so much. Satra betsaka daholo de zay no mamarana ny fiofanantsika androany mbola lefa misy karazana ohatra reny surveillance afaka atao de mbola isy ihany koa satria nisy ny fanirianareo anatrika an'ilay anao an'le fifana momba an'le Global Forest Watch sika de mbola ho avy ihany koa zany zay zavatra zay de mbola mifampitohy ihany efa ananako ny email anareo, anananareo ny emailako de afaka mandefa email sy mametraka fanontaniana de misaotra betsaka anareo rehetra. Misaotra.
Hello.
Thanks all.
Thank you, everybody.
Okay.